Section 13.5, Part 2, Example 3, Modeling with a cosine function. The water level varies from low tide to high tide as shown on page 863. What is the cosine function that models the water level in inches above and below the average water level? Express the model as a function of time in hours since 10:30 a.m. So if we look there, okay, we're going to pretend like on our graph here, we're going to pretend that this is 10:30 a.m. and we're going to start from here. And at 10:30 a.m. we're at low tide, the lowest it's going to be. And then the tide goes up until eventually we get to high tide. And high tide is going to happen at 4:40. Keep in mind though, one cycle, which is what we need in order to find our b value of cosine, is 5 points. Sine and cosine are each 5 points. So usually it's max, 0, min, 0, max. Here we have a negative value. We start low, which means since we started low, it's going to be a negative a value. Okay. We also need to continue this pattern to go all the way through. So if it goes from 10:30 to 4:40 to get half, that's going to be 6 hours and 10 minutes. 10 to 4, 10:30 to 4:30 is 6 hours, 10 extra minutes, which means it also has to be 6 hours and 10 minutes from our maximum to our minimum again. So our entire period is going to be 12 hours, 20 minutes. I'm going to rewrite that. Guys, 20 minutes out of a full hour worth of 60 minutes is going to be 1/3. So our period is going to be 12 1/3 hours. I'm just rewriting it so it's all labeled the same to make it a little bit easier. We also know that to find our b value, because what we're looking for is we want a function of time in hours. So we're looking for like y equals, we're looking for y equals a times cosine, b times, I'm going to use t here for time. We could have used x, we could have used theta. Doesn't matter what variable we're using. I just happen to be using time. So our b value is what we need to find here. We know our period equals 2 pi over b. b is the number of cycles in 2 pi. So our period is 12 1/3 equals 2 pi over b. So to get our b value, multiply both sides by b. And divide by 12 1/3. Again, if you wanted to here, we could take 2 divided by 12 1/3 and then put the pi back in. 12 1/3, guys, is 37 over 3. So when I multiply by my reciprocal, I'm going to have 2 pi times 3 over 37, or 6 pi over 37. And that's going to be my b value. 6 pi over 37 t. Now I need to find my a value. If we look back in the picture, it tells us that the distance between our highest point and our lowest point is 60 inches, which means that the top half, my picture's not to scale here, is half of it, 30 inches, and the bottom half is 30 inches. So our amplitude is going to be 30 inches. As far as finding amplitude goes, guys, if you're not sure, you can always take half the absolute value of the difference in our maximum and our minimum. So maximum minus minimum, and half it. So here we know that the difference between our maximum and our minimum is 60. Cut it in half because we want just how far away it is from that midline. So again, remember that our A is 30, but we also know that it's negative. So we have a negative 30. And there is our equation. Now, suppose that the water level varies 70 inches between the low tide at 8:40 and high tide at 2:55. What is a cosine function that models the variation in inches above and below the average water level as a function of the number of hours since 8:40 a.m.? So, when we're looking here, our start point is 8:40, and that's the low tide, and the high tide is at 2:55 p.m. Okay, keep in mind that we want a full cycle in order to figure out our b value, which we need for our function. So from 8:40 to 2:50 is going to be 6 hours and 15 minutes, which means that from 2:50 to the end is going to be 6 hours and 15 minutes. Minimum to maximum is the same as maximum to minimum. Same distance, same time. So this is also going to be 6 hours, 15 minutes. Okay, so we can find our total distance here by taking our 2 and adding them up. So the distance from low tide to high tide, the time is 6 hours, 15 minutes. And from high tide to low tide to finish out the cycle, 6 hours, 15 minutes. Which gives me a total of 12 hours, 30 minutes. 30 minutes is a half hour, so I have 12.5 hours. And that is my period. It takes 12.5 hours for one full cycle here of the tides. That's helpful because it gives me my b value. So once I have my period, I have 12.5 equals 2 pi over b. Multiply by b on both sides. Divide by 12.5. And b equals 2 pi over 12.5. I'm going to go ahead and simplify that, guys. We never want to leave a fraction or a decimal in a fraction. So I'm going to multiply by 2 top and bottom, and I get 4 pi over 25. Again, you could have typed that in your calculator as division and switched it to a fraction, and then put the pi in. Remember, we do the pi part last. So 4 pi over 25 is my b value. Again, I know my a value is going to be negative because I started out at my minimum. And it told us up here that the water level varies 70 inches from low to high, which means it's 35 on each side, half. So that's going to be my a value, my amplitude. Our amplitude is how far away from the middle are our maximum and our minimum. Here it's 35. So I have negative 35 cosine of 4 pi over 25 t. Example 4 is solving a cosine function. Suppose you want to find the time t in hours when the water level in problem 3 is exactly 10 inches above the average level represented by time equals 0. What are all solutions here of negative 30 cosine of 6 pi over 37t equals 10 in the interval from 0 to 25. So this is our height. Water level is exactly 10 inches above. So positive 10 is y, so we plug it in for y. That's where that came from. So if this will load here. Okay, so I'm going to go ahead and type in y equals negative 30 cosine of 6 pi, in parentheses, 6 pi over 37. I'm going to use x instead of t just to make it a little bit easier. And go ahead and close my parentheses. I have to do these as two separate equations, guys. So y equals 10 is my second equation. And that just gives me all my intersection points. So I can look here. All of them between 0 and 25. There I can see I'm at 28, so that's too far. So I have at time 3.75, at time 8.583, at time 16.084, and at time 20.916. Okay, those are the 4 points in between 0 and 25. And we could figure out the time from those after 10:30 if we wanted. So I'm going to go ahead and click those off. I'm just on Desmos here, guys. I could do, for the got it problem, 3 cosine of 2x or t would work. I should use x. Likes it better when we use x and y. Okay, and then I want to know when it's equal to negative 2. So I'm just going to go y equals negative 2. And we want to know from 0 to 2 pi. So I can do like 0 less than or equal to x less than or equal to 2 pi. And it'll even just highlight that area for me. So I want to know when it's negative 2. It looks like right here will be 1, 2, 3, 4. And I can zoom in and drag. Again, I can select my points just by clicking on where they meet, and it'll give me my values. So that's one way that we can do it, for now anyway. Real quick recap. As the terminal side of an angle rotates about the origin beginning at 0, its cosine value on the unit circle decreases from 1 to negative 1 and then increases back to 1. A non-translated cosine function can be completely described in terms of its amplitude and period. And here is your assignment for section 13.5.